Hey everyone, welcome to Automotive Diagnosis YouTube channel. This video is the second part of ABS module test and repair. On the first video that you can find the link right up here, I showed you how to read the wiring diagram for the ABS module and how to find the circuit on the ABS module circuit board. So obviously on the ABS module, we have some really common faults which are for ABS motor electrical or valve relay error. So these two are actually referring to two MOSFETs on ABS module that can be checked. First of all, you need to find them. You need to check the continuity or the resistance between the main connector, which is right here, which is at the back, and those components which are located right here. So I showed you how to find them, and step by step we checked all the circuit boards on the ABS module. But now on the second episode, I'm going to show you how to inspect the components for the MOSFETs and for the ABS solenoids. So if you remember, on the ABS module itself, we have three sections. So this is the ABS motor, this is the valve body, and here is the ABS module. And if I try to separate them, you have the valves here, and I'm gonna explain why we have this number of valves. Is there any other case that we have more or less valves on the ABS module, and what are they? I'm gonna explain this one. I will explain you guys how to check these valves because they are solenoid valves. And we're gonna see how we can check the MOSFETs as well on the ABS module, because one part is to check the board itself, and another part, sometimes you have a faulty component on the ABS module, which I'm gonna explain how to find it. All right, okay, let's start. First of all, we're going to focus on the MOSFETs, and if you remember, as I explained on the first episode, this MOSFET is for the ABS motor because it is located in the back. This one is actually to provide the positive and negative to the ABS motor. So this one is actually responsible to switch it on and off. But how can we test this one or the other MOSFETs we have here? First of all, I'm pretty sure I explained this one over there as well, but I show you here as well. So this MOSFET, if you check it on the board, you have a number. I'm not sure if you guys can see it right now or not, but there is a number written on the MOSFET. And if you search for the data sheet for this MOSFET, the number for this one, as I'm reading it, is 2N06LH5. All right, this is the data sheet for that MOSFET. So this data sheet is for that one. So as you see, this is a number 2N06LH5, and this is the MOSFET itself. And what we need is actually these two for testing the MOSFET. So we know that this MOSFET is the N-channel MOSFET, and between these three pins, we have the gate, which is responsible to switch on and off the MOSFET to connect the source and drain together. So this is gate, this is drain, and this is source. So what we have here, we have the structure of the MOSFET as well to know which one is the gate. So the one on the left, the one on the far left is gate, and then the middle one is the drain, and the last one on the right is source. All right. So how can we check it? Obviously, gate is actually the switching device, but between source and drain, as you see, we have a diode in here. So we can check it using the multimeter, and you know that the diode is going to block the electricity in one direction, okay, based on based on the diode direction. So if we provide the power to source and negative to drain, so it means electricity can go through the diode and can reach to there. So we will have a reading. But if you connect the positive on the drain side and negative on here, because diode is going to block the electricity, you shouldn't get any reading. So if you get the reading in the second test, it means your MOSFET is already gone and you have to replace it. All right, so on this one, based on what we explained so far, this is the MOSFET for ABS module. So between these three pins, this is the gate, this one is drain, and this one is source. So between these two, as I explained, we need to check if we have any reading. So on my multimeter, I'm gonna select the diode function. All right, as you see, I have the diode function here. And what I need to do, as I told you, because of the type of MOSFET that we have, we just need to provide the power to source, which is this one, and negative to the drain, which is this one on the middle. Okay, so I try to zoom it. Okay, you just need to see the reading as well. Okay, and this is the reading. So I give the black to the drain and red to the source. So we should have the reading, and this is the normal value. All right, so it means this one is working properly. But if I go the other way, if I give the positive to the drain and negative to the source, there shouldn't be any reading because my diode is actually blocking. So let's see if I give the positive to the drain and negative to source. I don't get any reading. So if you get any reading, it means this MOSFET is damaged and must be replaced. So I can do the same thing on the other MOSFET as well. So I have another one here, right? So I just put it right here so you can see. So between these three, again, I have gate, I have drain, and I have source. Okay, so what I do, again, I connect the black to the drain and red to source. So I'm getting a reading. So it means this one shows that the diode is okay so far. But if I swap it, if I give the positive to the drain and negative to source, I shouldn't get anything. Okay, so far so good. I can do the same thing in here as well, in this one. Positive to source, negative, positive to drain, negative to source, shouldn't get any reading as we have. But if I give the negative to drain and positive to source, I should get reading, which is right here, which is okay. So this is the first step to check our MOSFET. What is the second one? We can check actually the resistance between each two pins as well. So when you're checking the resistance between each two pins, you should get really high resistance. If you're getting low resistance, it means it's already shorted and you have to replace the MOSFET, like this too. I'm checking the resistance between each two pins. Between these two pins, so 4.2 mega ohms, you see it's really high value. Between these two pins, still high value, and between these two pins, this is quite big value as well. So if I'm reading really high value, it means that one is okay. But if I'm getting something really low, it means MOSFET is gone and must be replaced. So this is the first step for checking the MOSFETs. What is the negative? What is the second step? Second step is actually for checking the valves. In the previous episode, we talked about checking the circuits for the valves, but not for the valves themselves. So technically, is there gonna be any fault codes if I have any of these valves faulty? Yes. Normally you don't get one fault code per each valve, but you will have a fault code if any of these valves not working properly. Like there is a fault for valve error and the code itself C2380. So C2380 is the code for valve error. So if any of these valves is not working properly. So sometimes it's a mechanical problem. So valve is stuck or is not moving anymore because of the contaminated brake fluid. Or sometimes it's something electronic. Because you see the valves here, but the solenoid itself is right there. So it means if I show you something about the internal structure, so this is the structure of the valve. For each valve, we have the coil or solenoid right here. So this coil is going to create the magnetic field for us anytime which is activated, and the valve is inside. You see, this is the valve. Valve is inside. So when this one is magnetized, when this one is activated, it's going to create a magnetic field to move this valve inside. And what happens right down here, we have a passages which for this valve is already closed. This passage is coming from the master cylinder and is going to go to the wheel cylinder. So when this one is closed, there is no way for this brake fluid to go from here to the wheel. But when solenoid is activated, this valve should be up and brake fluid can travel all the way to reach to the brake cylinder. But how many of these valves normally we have? On this one we have 12. You see, we have 12 valves right here. This is not a valve, this is pressure sensor. So we have 12 valves right here. But is it going to be the same on all ABS or ESP modules? No. If you have only ABS, like this one shows you only ABS module. If you just have the ABS function, not TCS for controlling the traction, not ESP for stability program. So as you see on the ABS function only, we have 8 solenoids. 4 solenoids for inlet, 4 solenoids for outlet. So each wheel is gonna have 2 solenoids, 1 inlet, 1 outlet. So we have 4 inlet solenoid valves that normally we call the abbreviation ISV, and we have 4 outlet valves that we call it OSV. All right. So this is when you have only ABS. But in case you have ESP or TCS function, so this one is actually for this construction is for the Bosch 5.3, and as you see in here you have 12 as well, and between all the valves you already know that 4 valves are inlet, 4 valves are outlet, and what are the rest of them? You have 2 pressure increase valves, you have 2 pressure reduce valves. So totally you have 12 valves, and between these added 4 valves, they are actually for ESP and TCS function, and I'm going to show you how they work. So between these ones, again, I have 4 of these are actually inlet valves, 4 of them are outlet valves, and 4 others are for ESP and for TCS functions. And do we know which one is which? It's not written anything here. Obviously, nothing is clear right now, but just I'm saying these ones for your own references. On some of them, like the photo that I showed you, they are actually, the first line is for inlet, the second line for the outlet, and the 4 on the bottom, they are for ESP and TCS function. But this one is different. As you see, these 2 at the first line, these 2 are not exactly in the same line. The same, these 4, these 2, the same, these 2 on the bottom row. And these ones are not in the line as well. So what we have, if you look on the solenoids, you see different colors. You see, they are actually separated with different colors. So these four are same colors. You see they are blue. These four, and these two are red, like these two. I have 4 solenoid with blue color, 4 other solenoids, 1, 2, 3, 4. They are red as well. So between these, each of these 4 are for inlet or outlet valves. All right. So we have 4 for inlet valves, 4 outlet valves. We already found them. And in the middle, we have 2 yellow and 2 brown. 2 yellow and 2 brown. And what are they? 2 of them are actually the pressure increase valves, 2 of them for pressure, 2 of them for pressure reduce valve. So for ESP and TCS function. Why am I referring to these ones when we won't have any individual or separate fault codes for the solenoid valves? Because we're gonna need them for checking the resistance. We're gonna make sure if our resistance value is okay, because between these solenoid valves, the resistance value is not exactly the same between all of them. So you need to know which ones of these solenoid valves are exactly, which one of these solenoid valves have the same amount of resistance. Okay, but how can we check them? For checking them, so you see the solenoid valves are here. If you look deep down inside the solenoid, at the very bottom, I believe you can see you have 2 wires over there. You have 2 pins over there which are for the solenoid, which are already soldered to the board. But am I gonna go down there to see to reach to those pins to check? No, because they are already soldered to the board. So maybe you don't see them right now here. Maybe you don't see them right now here, but as you see on the photo right now, these 4 are exactly the blue ones. So this one here. So this one for the solenoid, this one is for the solenoid too. So, and this is the outer one, this is the blue one, and these 2 for the blue ones as well. So these 4 should give you exactly same amount of resistance. And the red ones are just right here, 2 at the top, these 2, and 2 at the very bottom. And the others at the middle row. So I have 1 solenoid here, 1 here, 1 here, and 1 there. And if you remember, this one and that one should give you the same resistance, and these 2 are brown ones which are going to give you same resistance. So if you see the color codes, I'm going to show you right now here. Blue ones, so these are red ones, so these 2 are yellow ones, and now I'm showing you the brown ones. So what am I going to do? I can check the resistance for each of them because they are solenoid valves and they have the resistance. So my multimeter should be on resistance function. And what I will do, I start by checking the resistance from those blue solenoid valves, the outer ones. As you see, if I zoom it right here for a while, I'm actually checking the resistance between these 2 because they are 2 ends of the solenoid valves. So if I show you the multimeter right now, so if I check the first one, 8.9, 8.8. So I go for the second one in the same group. So I check from here, these 2. I'm getting 8.8 again. And the other one is down here. If you remember, they were on the outer sections. And the last one is just right here. Again, 8.7, 8.8, they are so much close. What about for the red ones? So they are okay. If one of these resistance is not in the range, is very different from the others, it means that solenoid valve is already faulty. So I have these two so red ones are these two and these two down here. All right, so I'm gonna check them one by one. So this is the first one, 5.9. Second one, 5.9, and this third solenoid valve right here, again 5.9, and the last one 5.9. You see, so the first group of solenoid valves, the first 4 solenoid valves gave us 8.8. So all of them were similar, they were okay. The second 4 solenoid valves, we are getting 5.9. So these ones are okay as well. So we are left with 4 solenoid valves. And between these remaining solenoid valves, they are similar 2 by 2. So this solenoid valve, so this one and this one, if you remember, they were in yellow color, so they are exactly similar. So I'm checking this one first. This one is 8.7, and the other similar one, 8.7. And these two internal ones in brown color, they should be similar. 4.3 and 4.3. So one more time, just to remember, is out of these 4 solenoid out of these 12 solenoid valves, we have 4 inlet solenoid valves, we have 4 outlet solenoid valves, and here we have 4 more solenoid valves. They are for ESP and TCS functions, or pressure reduce or increase. I can show you the I can show you the internal structure right here. So this is your brake booster and master cylinder, and the whole thing, what you see here is actually the ABS module, the valve body, and this is the ABS motor itself. So the whole thing is the ABS module. I'm gonna attach this diagram to the description, so you can find the link in the description to download it if you are interested. So these are actually wheels: left rear, right front, left front, right rear. So we have 4 wheels. All right. So this is the ABS motor itself and pump elements. So this is the input from the master cylinder. So this is the input from the master cylinder to the ABS module. So what we have here, if you see ISV for inlet solenoid valve. So we have one ISV for this, another ISV, ISV, ISV. So we have one ISV or inlet solenoid valve for each wheel. We have one OSV or outlet solenoid valve for each wheel, and these 4 at the top, these 4 are actually for the traction control system. All right, so this is the electric shuttle valve and this is the traction control valve. So we have 4 of them, 2 okay for each side, 2 for each side. As you see, this one is actually for increasing the pressure when ESP or TCS function is operating, because this one is normally closed. When ESP or TCS function is operating, this one is going to open to provide more brake fluid to the pump to increase the pressure. And traction control valve is normally open, but when ESP or TCS function is operating, this one is going to get closed. For the other ones, as you see, ISV or inlet solenoid valve is normally open. So when you do the normal braking, just nothing is happening. ABS is not functioning, or TCS or ESP not working right now. If you are just doing the normal braking, this one is normally open. So the brake fluid is gonna come all the way to go from here to the wheel, all right? If nothing is happening, if wheels are not about to lock up. But if any of these wheels, like this, if this wheel is about to lock up, ABS is gonna open the outlet solenoid valve to release the pressure. So the sequence is just like that. The pressure is provided to the wheel from inlet solenoid valve, and right after brake is applied, when brake fluid reaches to the enough pressure to grab the wheel, ABS module is going to close the ISV valve to maintain the pressure, to hold the pressure inside the brake lines. But right after that, if ABS detects that one wheel is about to lock up, it's going to release the pressure by opening the outlet solenoid valve, which was normally closed, but now is going to open. So what happens, if this wheel is about to lock up, the pressure from here, brake fluid from here, is going to get released through the ABS pump. So this wheel is going to start spinning again because the pressure is released. And after it starts spinning again, when ABS module detects that this wheel is not locking up anymore, it's gonna close the OSV and open the ISV to provide the pressure again to stop the wheel. All right, so anything else on this one? Yes, there is something else. So normally, as long as we know that our solenoid valves are soldered to the board from here, okay, these ones that we saw earlier, we can check the continuity between the MOSFET, between the solenoid drivers and its solenoid to make sure they are actually connected to the MOSFET. So this is the last step. I'm gonna turn this one on, and on the continuity function. Okay. So what I do, I start from this MOSFET and I touch the valves one by one. All right. Okay, so it means I was trying to check if all these solenoids are connected to the MOSFET. We already checked the solenoids resistance. We checked the connection between the solenoids and between the driver MOSFET as well to make sure they are okay. The other end of the solenoid obviously is controlled by ABS module to drive it, to activate it or energize it when it is needed. I hope this video was informative and helpful for you guys. Thank you very much for watching and supporting the channel. If you find the video helpful, please don't forget to like and to share it with your friends. Thank you very much.